Choo-choo! All aboard the History Express with tester, evaluator, and grandpop of WiseHooterLearning. Today we're off on a grand adventure to discover the fascinating world of trains. Grandpop has always loved trains. He grew up in a town with a famous steam train called the Skunk Train. He loved seeing it roll by, and it made him want to learn more about trains. So buckle up, because we're about to embark on a historical journey faster than a runaway freight train. Imagine a world without trains. No thundering steam engines, no sleek bullet trains, no chugging freight lines hauling goods across continents. It'd be a right mess, wouldn't it? Thank goodness for brilliant minds and their incredible inventions. Trains have been around for donkey's years, evolving from humble beginnings to become the powerful, efficient machines we know and love today. We'll uncover how these iron horses went from puffing steam to becoming the green machines of the future. Before we had those mighty locomotives thundering across the land, we had to start somewhere, didn't we? And that somewhere was with the invention of the wheel. But just having wheels wasn't enough, was it? We needed a way to guide these wheeled contraptions, to keep them from veering off track. Enter the ingenious idea of rails. By laying down tracks, we found a way to guide our vehicles, creating the very first railways. The invention of the steam engine revolutionized transportation forever, providing the muscle needed to propel trains forward, ushering in a new era of speed and efficiency. Now picture this. The year is 1804. And a fella named Richard Trevithick unveils his latest contraption, a steam-powered locomotive. It wasn't exactly a looker, more like a big, clunky kettle on wheels. But boy, could it move. Trevithick's locomotive, affectionately nicknamed Puffing Devil, trundled along a tramway in Wales, pulling a hefty load of iron and passengers. This groundbreaking invention set the stage for a steam-powered revolution. Engineers and inventors, inspired by Trevithick's creation, set about refining the design, making locomotives more powerful and efficient. The race was on to build faster, stronger, and more reliable steam engines. One name stands out from this era of innovation: George Stephenson, a brilliant engineer who's often hailed as the father of railways. The rocket's triumph wasn't just about winning a race. It marked a turning point in transportation history. People realized the immense potential of these iron horses, as they were often called. Railway lines began to snake their way across countries, connecting towns and cities like never before. The familiar sight of steam locomotives, with their puffing smoke plumes and rhythmic chugging, became synonymous with progress and adventure. Steam trains became the workhorses of the Industrial Revolution, hauling coal from mines, transporting raw materials to factories, and carrying finished goods to markets. The age of steam had truly begun, and with it, a sense of wonder and possibility gripped the world. People marveled at the power of these machines, their imaginations ignited by the promise of new horizons and adventures just a train journey away. Now it's time for a shout-out. Shout-out from tester, evaluator, and grandpop to Nathan, Justin, Jessica, Yvonne, Rich, Isla, Olivia, Luca, Charlotte, Larry, Trisha, Dale, Lawrence, Eyelid, Iona, Katrina, B, Mariah, Bryce, and of course Elspeth. Faster, further, stronger advancements in steam technology. As the steam engine revolution chugged along, clever engineers weren't content to rest on their laurels. One significant improvement was the development of multiple-cylinder engines. Instead of relying on just one cylinder to push the piston back and forth, they added more. 2 cylinders, 3 cylinders. Why, some steam locomotives even had 4. Having 4 made the engines run more smoothly and increased their pulling power. Another breakthrough was the use of superheated steam. By heating the steam to even higher temperatures, engineers discovered they could squeeze even more power out of it. These advancements meant trains could travel longer distances without needing to stop for water or fuel as often. They could also haul heavier loads and climb steeper gradients, opening up new possibilities for railway lines to reach even the most remote corners of the world. The age of steam was truly steaming ahead. The cylinders in a train engine are the part of a steam engine that converts steam energy into mechanical power to move the locomotive function. The cylinders house the pistons, which are driven by steam pressure to create a reciprocating motion that turns the locomotive's wheels. Design. The design of the cylinders, including their size, configuration, and arrangement, affects the speed and force at which the pistons move. Construction cylinders were originally made of cast iron, but later became made of steel. The last large American locomotives had cylinders that were part of a one-piece steel casting that formed the locomotive's main frame. Sparks of change. The rise of electric locomotives. While steam engines were busy puffing their way into history books, a new kid on the block was starting to make some noise: electricity. These early electric locomotives weren't exactly sleek speed demons. They were more like clunky trams with a penchant for sparks. But they had one big advantage over their steam-powered cousins. They didn't need to carry around all that heavy coal and water. Instead, they drew power from overhead lines or electrified rails, making them cleaner and quieter to operate. One of the earliest successful electric railways was built in Germany in 1879. It was a demonstration of the world's first electric railway at the Berlin Trade Exhibition. It was a short line, but it showed the potential of electric traction. As technology improved, electric locomotives became more powerful and efficient, eventually challenging the dominance of steam. Power from within. Diesel engines enter the scene. Just as electric locomotives were finding their feet, another contender entered the ring: the diesel engine. Diesel engines had their own internal combustion engines, just like your family car, only much bigger. These engines burned diesel fuel to create power, which turned the wheels. They were like self-contained powerhouses on rails. The first diesel locomotives appeared in the early 20th century, and they quickly gained popularity. They were more fuel-efficient than steam engines and didn't require the complex infrastructure of electric railways. Plus, they were powerful enough to pull long trains over vast distances. The number of cylinders in a diesel train engine varies by model, but can range from 8 to 20 cylinders. The rise of diesel engines marked a turning point in railway history. Diesel locomotives began replacing steam engines on many lines around the world, becoming the workhorse of the railway for much of the 20th century. It's time for a shout-out. Tester, Evaluator, and Grand Pop send a shout-out to Eriko, Himari, Hina, Himawari, Nagisa, Kasumi, Yui, Hoshiko, Izumi, Kazuko, and of course Rin. Sleek, speedy, and electrifying high-speed rail takes off. With the advent of electricity and advanced engineering, a new breed of train was about to emerge: the high-speed train. One of the pioneers of high-speed rail was Japan, which unveiled its iconic Shinkansen bullet train in 1964. The Shinkansen, with its aerodynamic design and powerful electric engines, could reach speeds of up to 130 miles per hour. It revolutionized travel in Japan, making it possible to travel between major cities in a fraction of the time it used to take. The success of the Shinkansen sparked a global high-speed rail boom, with many countries investing heavily in building their own high-speed networks. Strength in numbers, from steam giants to powerful freight trains. While speedy passenger trains were grabbing all the headlines, let's not forget about the unsung heroes of the railway, the mighty freight trains. Modern freight trains can be miles long, consisting of dozens or even hundreds of wagons pulled by incredibly powerful locomotives. These locomotives, often diesel-electric hybrids, generate thousands of horsepower, allowing them to haul millions of tons of cargo. Freight trains are the backbone of global trade, ensuring that goods and materials reach their destinations efficiently and reliably. Painting the town green trains get environmentally friendly. All that coal guzzling and diesel burning wasn't exactly doing the planet any favors, was it? Smoke billowing into the sky, soot covering everything. Not very eco-friendly, eh? But don't you worry, our clever engineers weren't about to let those trains become environmental villains. They put on their thinking caps and got to work on making trains more environmentally friendly. One of the biggest challenges was reducing emissions. The quest began to find cleaner sources of energy to power these iron horses. Remember those electric trains we talked about earlier? Well, they were about to make a big comeback, and this time they meant business. Back to the future. Electrification makes a comeback. That's right. Electrification is back with a bang. And this time it's not just about short city lines. We're talking about electrifying entire rail networks. By using electricity from renewable sources like solar, wind, and hydropower, we can power trains without producing harmful emissions. Electrifying an entire rail network isn't as simple as plugging in your phone charger, mind you. It's a massive undertaking that requires upgrading infrastructure, installing overhead lines or third rails, and investing in new electric locomotives. But the benefits are well worth it. Electric trains are not only better for the environment, but they're also quieter and more efficient than their diesel counterparts. Many countries are already leading the way in rail electrification, with some boasting almost entirely electrified networks. Hydrogen on the horizon, choo-chooing into a clean future. The green train revolution doesn't stop at electrification. There's another contender in the race for clean train technology, and it's powered by the most abundant element in the universe, hydrogen. Hydrogen trains use hydrogen fuel cells to generate electricity which powers the motors. The best part? The only byproduct of this process is water vapor. Talk about clean energy. Hydrogen trains offer several advantages over traditional diesel trains. They're much quieter, produce zero harmful emissions, and have a longer range. While hydrogen train technology is still in its early stages of development, several countries are already testing and implementing these trains on their networks. As research and development continue, we can expect to see hydrogen trains playing an increasingly important role in the future of sustainable transportation. Hydrogen has the highest energy content of any common fuel by weight, about 3 times more than gasoline. But it has the lowest energy content by volume as a liquid, so a lot of work has gone into the best and safest way to store the hydrogen. We will go further into this in another video. Battery power on track. Storing sunshine for the journey. Let's talk about another exciting development in green train technology, battery-powered trains. Battery-powered trains offer a fantastic solution for routes that are difficult or expensive to electrify. They can store energy from the grid, including renewable sources like solar and wind power, and use it to power the train. These trains are particularly well suited for shorter routes, branch lines, or areas with limited electrification infrastructure. They're also much quieter than diesel trains and produce zero emissions during operation, making them a more environmentally friendly option. As battery technology continues to advance, we can expect to see even more battery-powered trains hitting the tracks, providing a cleaner and quieter alternative to diesel when the electricity is sourced from a renewable source like tidal, wind, or solar. As with most fuel sources, it's all about how much energy density you can expect from a specific weight of the batteries. The higher the energy density, the further you can go. So scientists are working hard to develop batteries with higher energy density that are safer than the current technology in use. Trains of tomorrow. Faster than a speeding bullet. Well, half as fast. Hold on to your hats, young engineers, because we're about to enter the exciting world of future trains. Imagine boarding a train that whisks you from London to Edinburgh in the blink of an eye, or from New York to Los Angeles faster than you can say cheeseburger. Thanks to some brilliant minds and their thirst for innovation, these futuristic visions of train travel might not be too far off. Engineers are constantly working on ways to make high-speed trains even faster, using advanced aerodynamics, lightweight materials, and powerful magnetic levitation to reduce friction and increase speed. We're talking about trains that could potentially travel at supersonic speeds, rivaling even airplanes for long-distance travel. Imagine the possibilities. Maglev Magic, floating into the future. Maglev stands for magnetic levitation, and it's as cool as it sounds. Using magnets, maglev trains float above the track, eliminating friction. It's like something out of a science fiction film. Japan's SC maglev trains set speed records at 374 miles per hour. Maglev trains are energy efficient and super quiet. Imagine traveling from London to Paris in under an hour. Maglev technology could revolutionize transportation. The Hyperloop hype, traveling at the speed of sound. And now, for the grand finale of our journey into the future of trains, we have to talk about the Hyperloop, a very old idea with a new name. An engineering project proposed in 1825 and called the London and Edinburgh Vacuum Tunnel Company was to be established with the capital of £20 million sterling. The concept was based on a 1799 proposal made by George Medhurst. Unfortunately, like many ideas, the idea was proposed before we had the technical ability to make it happen, so it was mainly forgotten. Elon Musk called his version of it the Hyperloop. It aims to transport people and cargo at incredible speeds through a near-vacuum tube. Picture this. You step into a pod-like vehicle and within seconds, you're whisked away on a cushion of air, propelled through a low-pressure tube at speeds approaching the speed of sound. It's like something straight out of a sci-fi movie, but the Hyperloop is closer to reality than you might think. By traveling through a near-vacuum environment, the Hyperloop eliminates air resistance, one of the biggest factors that slow down traditional trains and cars. This allows the pods to reach incredible speeds, potentially exceeding 700 miles per hour. That's faster than most commercial airplanes. While the Hyperloop is still in its early stages of development, several companies and research teams around the world are working hard to turn this futuristic vision into a reality. And if they succeed, the Hyperloop could revolutionize transportation, connecting cities and countries in ways we never thought possible. Trains, chugging into the future. We've journeyed from the puffing steam engines of the past to the sleek green machines of the future, connecting people, places, and possibilities. Tester, evaluator, and grandpop at WiseHooterLearning would like you to imagine trains that travel at supersonic speeds, powered by nothing but the sun and wind. We need you brilliant minds to grow up thinking of how to improve all forms of transportation so they become cleaner, more efficient, and of course safer. Not everyone wants to make a career out of improving our technology, but I am very sure that some of you do. Regardless of what career you end up in, all of us can work towards having a better world. It just takes a lot of small steps in the right direction. So put your brilliant mind to work and let's see what ideas you can come up with. The world of trains is always moving forward, chugging towards a brighter, faster, and greener future.